Please welcome Scott Coleman and Dennis Lanahan to the S4 sponsor stage.
Right, thank you very much. So this is the sponsor stage. I'm not going to be shy about talking about the company and what we do because I think that's what is most relevant to folks here. So our title is a little provocative, right, with the intent to basically talk about the fact that what we're doing is not the status quo. We're trying to do things a little bit differently and raise awareness around that. I'm going to sort of walk through, set up the details of what Dennis is going to talk about in terms of presenting the Department of Homeland Security, some guidelines and strategies as they come from, where our stuff fits in those strategies, and how companies are actually deploying those today. So, this is the work. All right, so you've got the IT network, right? And obviously no one wants to be the one that ends up stepping in the hazard there that might be there. And at the same token, right, you don't want to be the one that's saying, oh shit, we had a breach in our OT network, right? So we're playing a little bit off on words there. But without unhackable solutions, and I'll talk about unhackable in a second, and best practices, you'll be either waiting for the shit to hit the fan, right, or playing dodge the doo-doo all day long as you figure out what's wrong with your firewall rules or other things that can be susceptible to images. Our premise is, and you have a lot of companies that are saying the opposite, right, is that you can't defend. Actually, the last presenter, right, he had the castle picture up there and said you can't defend anymore. You got to, once you're going to expect to be that there's going to be intrusions, and because of that, the defenses have gone down. But what we're saying is avoidance and prevention is much better than trying to clean up after the fact, right? So our solution is really around becoming unhackable. And a lot of people question why we say that, what that means. And we do have a technology. It's a data diode technology. And we'll explain a little bit about data diodes and how they work. I know some people probably at least have heard the term before. Some people may be somewhat familiar with them, but we're going to make sure everyone understands how they work and why we take that position. So if you was unhackable, right, you'd have no malware. You could have no intrusions, you have no corruption or manipulation of data, no locking of data, no stealing of data, et cetera. And that's really what we want to be to. That's the important part. Sort of intrusion or detecting things after they have occurred really sort of is past the point, right? Much better to prevent that than to try and recover from it. Now, you're not going to be able to prevent everything, but the whole idea here and what we're presenting is to limit the possibility of those intrusions. So, real quick about OWL and what we do. So we've been doing this for about 20 years now. So this is not new technology. This is technology that existed. It's been improved upon recently over the years, but it's not new. We are US owned and operated. Half of our business is into the DOD and Intel side of the things. So we have a lot of customers that are deploying our technology on ships, UAVs, in enterprise applications, et cetera. And then we have a part of our business that is for industrial controls, and the company's pretty much split 50-50 between those two entities. We've got over 40 different technology patents on this type of solutions, and we're selling sort of globally around these products. So our premise is that hardware works, right, and software lurks. Software lets things sort of hide, right, things that can't get. I think Brian Owen was just talking about dead bodies in the closet, right? So the thing that allows that to happen is software. Those hidden rules, the misconfigured something or others, the thing that wasn't disconnected when it should have been, et cetera. And that's where we're taking a different position to say, hey, if you have hardware is known as a specific entity, and it can do certain things. And if you know what the bounds of that are, and it can only do certain things, then it lets you protect better. And sort of final point, firewalls are not hardware, right? Firewalls run on an appliance potentially, but there's a lot of software firewalls, and they're really governed and controlled by the rules that are set and the parameters that they implicate, not in the actual hardware itself. Okay, so 583. It's the average number of connections that companies have, enterprises have to external parties, right? So it's a very large number. And really we're talking about is how do you manage that number better? Everyone's got finite resources. I think a couple of speakers talked about that this morning, about resources and what do you manage your resources, and looking at how you're going to apply your resources to things that have the highest risk, right? And that's really what it's about is, A, can you reduce that number? And B, once you do that, you have a smaller set of things that you have to manage and apply your resources to. So we'll mention that 583 a couple of times. So each of those 583 things represents a hole in the network. Right now, people say, oh, it's a pinhole, I let this in. I don't think any threat actor, anybody trying to do bad things against your network cares how big a pinhole is or isn't, right? Electrons can get through pinholes. So the more of those openings you have, the more threats you allow into the network potentially, right? Now, not to say they're not for good things. There's good reasons why you want to share data from your OT environment out to the IT environment. No one's saying that's not a bad thing to do. Just got to make sure you have the right reasons and you have the right controls in place. So there's the cloud, obviously, that people are pushing data to. You have the Internet of Things. You have digital transformation. So all these things are driving additional and more reasons to connect to the outside world. But can we do it in a way that doesn't also increase threats simultaneously? So what are some of the reasons why you would have those external connections? Right? These are probably fairly obvious, but you may have cloud applications, SCADA controllers, safety systems, mobile devices, edge computing, robotics, industrial automation, etc. All those things are producing data that needs to be shared. So whether it's a turbine that needs to be shared, information for maintenance, preventive maintenance reasons outside, if it's production information that you're generating that needs to be seen, if it's data for remote monitoring purposes, et cetera. It's all valid data and all valid reasons to have those connections, but is there a way to make those secure? So let's look at a couple of strategies for mitigating threats, right? So the first one, of that 583, which ones are legitimate, right? So the only way you know which ones are legitimate is to take your inventories, right? So who has access? What do they have access to? Basically, you can't secure what you don't see or what you're not aware of, right? So unauthorized or unknown connections are actually very common, and those are things we're trying to prevent. And that's part of what the DHS is going to show in the guidelines that Dennis is going to mention. Okay? This goes back to exactly what we were talking before, right? So what are those things that are highly risky and of high value to? So that's where you focus the resources, right? The severity of infiltrating something that's this end of the scale is where you focus those limited resources. And if we can help mitigate or minimize the number of those things and therefore make them lower risk and lower value targets, then that's really what we're going to try and do. So out of that 583, right, which ones fall here, which ones need the most protection, and how can you get the numbers to be smaller? Okay. Defense in depth, I think Brian Owen actually mentioned that again this morning. Right, so this is something you can't forget about. There is no silver bullet to protection, but it's make sure you're adding the right layers at the right point that provides the correct protection for you. And then finally, zero trust, right? So unlike trust but verify, it's really verify everything and trust no one, right? So assume, right, that you can't trust anything. And how do you put the things, the places, the activities in place, the protections in place so that your workflows, your network, your devices, and your people are all doing the right thing? Or can you put something in place so your people don't have to remember to do the right thing and it's done automatically? We had a customer recently who did an internal audit. They failed their internal audit, and it wasn't because, this was really primarily looking at industrial firewalls, and it wasn't the reason they failed the audit wasn't because the technology didn't work, it was because the people running the plant, running the refinery, in fact, were focused on their day jobs and not on updating and keeping the firewalls current. So they failed because the people failed, because the workflow failed, not because the technology failed. So if you have a technology that doesn't require you to constantly be updating it, that you can actually truly set it and forget it and let it run, now you're reducing your threat vectors. And Dennis can probably mention that a little bit more. So So recommendations for implementation. So this comes from the Department of Homeland Security. They published these a couple of years ago. I don't know if folks are familiar with these. They actually had 7 strategies. And they said if these 7 strategies had been implemented, then of all the threats and breaches they had found and were reported to them, 98% of them would have been prevented. Not sort of discovered after the fact, but actually prevented, stopped before they occurred. So 3 of these strategies actually call out specifically data diodes and what they do and how they work. And how they're important in those areas. And that's really what Dennis is going to work into. So you'll see there, it's about reducing the connections in the network. So how do we reduce those 583 connections, right, to something more manageable? Converting two-way connections to one-way out of the plant. So you think about that diagram I showed. We had the plant in the center and all those remote connections. Well, typically those are all two-way connections, right? But how many of those could be one-way? How many could we take data and just push it to those folks that still need the data without having them to come into my network, right? And then for converting two-way connections into one-way into the plant, right? So these are my patches that need to get into the plant, right? These are the things that I have to get in there, but I want to vet them. I want to make sure that those are controlled. And then finally, after you reduce those and converted those, then I still have two-way connections, right? We can't ever get away from having some kind of two-way connection. I'm going to need to be able to have remote access from folks. So when I do that, that's where I focus my resources, right? So if I can do the other conversions, I can limit or eliminate some of those connections and leave myself with just the two-way ones. That's where I can focus those becomes my highest threats and those ones I put most resources against. So it's all about managing the 583 third-party conversions, or connections rather, and converting them to something easier. So from here, Dennis is actually going to walk us through the actual different technologies and talking about how those DHS strategies are implemented in the networks.
All right, thank you very much, Scott. Nothing like being the last presenter to keep you guys from lunch. So the thing that's really interesting about the DHS strategy, the reason we talk about it, in my opinion, is it gives a very clear roadmap for asset owners to understand how new technologies can be implemented in a way that they wouldn't necessarily think of on their own. So part of the strategy here is that one-way solutions work. And that's what OWL implements, is one-way solutions, one-way links, in order to segment and mitigate risks between different networks, right? And we all know that right now in the airport, in the airline industry, since 9/11, is new implementation for segmentation was put in place that enforces one-way flow of people into and out of the terminal. So the thing that's very interesting about the Department of Homeland Security is they're taking that model, which is what OWL has always done for network segmentation, and giving the asset owners a different way to think about things. And as Scott had mentioned, forcing all of the data flows to being one way out wherever they can be one way out mitigates the risk. Data flows out, absolutely nothing can go in. Think of remote monitoring without remote access. The ability to have access to data that comes out, but not access to the network or the machines that actually produce that data. For the environment where you need to get information in, one way in provides that segmentation that allows you to get data in that's not encumbered by the security policies of data coming out. And in that controlled environment, again, just like the airport environment, you can put content examination on that data flow to make sure that the data itself is not a risk. So within all of this is the defense in depth continuum of all the different assets that are out there and the mechanisms by which you're using in order to secure them. The data diode technology that OWL represents is out here on the far right-hand side, and this particular chart coming from an industry think tank group and analyst company, I would actually propose that the data diode needs to be moved beyond the air gap, because our technologies implement an air gap, maintain that air gap, maintain that physical separation between the networks, but then allows the data and only the data to flow. And because of the hardware enforced aspects of what we do, we're getting the physical enforcement of that mandatory separation in hardware that cannot change. It's unhackable because, the reason we define that is with the protocol break that we put in place and the physics within the product itself does not have a reverse channel. So there is no software attack that can ever cause it to work in reverse. It can't work in an unknown state. It either works one way or it doesn't work at all. And that hardware enforced policy is what our customers like because they know it, it's defined, and it can't change. It either works one way or it doesn't work at all. So invulnerable to malware, the reason, again, we bring that up is malware is a software attack. And the hardware is hard, the software is soft. There is no malware attack that's going to cause it to work in reverse or cause it to work in an unknown state. And then little to no ongoing management is really important to our customers because they know the security policy of the one-way enforcement is in hardware. It's not in firmware, it's not in software. So there is no software update that OWL can provide or firmware update that we can provide that changes that hardware enforcement. It does one thing only, and they enjoy that security policy because they know that they can set it, they can forget it, and they can't update it. So the data diode use cases are fairly straightforward. And I think some of the best ways to think about this is, again, there's 3 implementation phases. There's converting all of your data flows, as many as possible, to one-way out. So the data transfers from remote assets is the ability to collect that data from the asset, either move the data directly from the asset out from the OT to the IT environment, or put that asset data into a historian and replicate the historian out. So it's pretty straightforward in that particular use case. Micro-segmentation, and at our Cabana we'll have an example of our new micro-segmentation device, which is an entry-level, low-cost solution, hardware enforced, that allows micro-segmentation at the individual asset level. So instead of necessarily trying to run at the perimeter, we can take the micro-segmentation down to the individual asset level. So in terms of OT and IT convergence, that is what a lot of our customers are talking about, is they want to be able to get that OT data from the OT environment, pass it securely and safely to the IT environment or the cloud environment, wherever it needs to go, either at the boundary level or at the individual asset level, and ensure that the assets that are producing that data are protected from outside influence. Again, we can do it at the boundary layer, or we can do it at the micro-segmentation layer. So remote monitoring is always one of the big things our customers talk about. And we spend quite a bit of time with industry software companies helping them convert what is typically a remote access to gain the data, to helping the OEMs convert that to a one-way push of data. So instead of having to have remote access in order to collect the data, flip the paradigm, convert the data, push it out one way. You always have an exact replica and a copy from OT to IT whenever you need to use it. You don't need to dial in, you don't need to roll a truck, those types of fixes in that environment. So how does a diode work? I'm not going to get into a ton of detail here, but on the source network, there is a photo transmitter that sends data, light, one way, that can never receive light. Directly across from it on the destination network, there's a photo receiver that receives that data in, that light in. It can never send data. So we lock down the endpoints of those 2 networks. The other thing that we do here in this environment is we introduce our own proxies and then also an ATM protocol break. And that ATM protocol break ensures that there's no passing of IP information across the networks. So in effect, what you get here is the ability to connect to a source network, flow the data and only the data, the ability to connect to the destination data, and then disseminate that data to the final destination with 100% confidentiality between the 2 networks. So at the Cabana event right after this, I can certainly go into more details of how the technology works. This particular product right here is one of our newest products, which is a entry-level, single-purpose device that is designed to sit at the microsegmentation level or even the individual asset level to protect an individual asset. So here at this conference, you've heard quite a bit of people talking about, well, do you have the ability to patch everything? And the answer may be, no, we don't, because that particular version of something is unpatchable, the manufacturer doesn't keep it up, whatever the reason may be. This particular device here for diode allows individual asset protection at a price point that's affordable. And we can talk more about that at the Cabana as well. So the other thing you'll notice here is all of our solutions are built on a hardened Linux OS. Self-protection of our security device is as important as protection of the network boundary. So we spend quite a bit of time with our products to make sure that the products are secure as they are delivering the security that they're designed to deliver. So use cases. So the use cases and a lot of new potential customers to Owl are always interested in how the products are being used. And in this particular case, there's a pipeline pressure sensor in oil and gas where that device is outputting data. It might be Modbus data, it might be OPC data, it could be SIM data, it could be many, many different types of data. Our proxies that sit next to that device have the ability to collect the data. We send it across the data diode, right? So you're going from transmit to receive, and then out to the various different locations where that data needs to be delivered. For us, on the destination side, whether that data delivery is to your own infrastructure or your own hosted environment or a third-party hosted cloud, as long as we have a physical route to deliver that data to the final destination, we can deliver that data to wherever it needs to go. So in this particular case, a customer that's moving more than just simple information, but they've got a database of information. They've got a web server of information. They've got more stuff protected behind the diode that's in a private, secure environment where they need to move multiple streams or larger volumes of data and then push it out to the various different operations center. And again, in this particular scenario, data is flowing out one way. The bad actors from the outside can't get in. And any malware that might be on the inside, because we use a non-routable protocol break, malware doesn't have the ability to propagate out. So if there's an insider threat where malware is launched in the OT environment, the data diode is also going to protect the outside environment to ensure that that malware can't escape out across our non-routable protocol break. So one of the use cases, or the third use case that the DHS talks about, so they talk about first converting to one-way out, converting to one-way in, and after you go through that process, you may very well have a connection or two that absolutely requires command and control request response across that boundary. And in that particular environment, we have created a product that we call Recon that uses two sets of data diodes in reverse of each other and a TCP/IP proxy that allows us to split and join that TCP/IP session and maintain it on both sides of the networks. Now, most people at this particular point in time say, well, that's no different than a software firewall. And I suggest that it is absolutely extremely different than a software firewall in that it is hardware enforced across the boundary. It's non-routable across the boundary. The non-routable protocol break to ATM. It's 4 physical pieces of hardware. It's actually 4 physical servers that maintain the connection to the diodes themselves, and it's not a single piece of software in the middle negotiating routable traffic with software security policies. So in an environment like this, it requires 4 individual setups to enable and turn on one route, which is an interesting distinction because our products ship basically closed. Nothing can go through them. The asset owner or the installer has to physically turn on and set up each one of those routes. which again, typically very, very different than a software firewall in that environment. So we can talk more about that. We do have customers that deploy one way out, one way in, and have now gone to this model with Recon as well for those particular connections that have to be command and control across the boundary. The other piece that the DHS talks about in this particular environment is each one of those connections should be across its own single device. You can turn it on when you need it, turn it off when you don't, because obviously when it's turned off, you're much more secure. And by breaking out those 3 different use cases to one way out, one way in, and then Recon for bidirectional, is the security policy and the implementation of one does not affect the others. Which again, very different than a software firewall, because we have a number of customers that come to us after they've had to unplug their software firewalls because stuff hit the fan. And in our customers now that have diodes deployed, they maintain the one-way out connection and they don't turn that off. So they limit capability, but they're not completely blind to the operations of the OT environment. That data, that monitoring data still flows out. Yes, question. Yeah, so I think the question is how does the diode help mitigate zero-day attacks or self-propagating viruses? Is that a fair summary? So what we do that's very, very uniquely different in our non-routable protocol break is we extract the data payload out of the packet that comes to us, and we put the data payload into an asynchronous transmission cell, an ATM cell. And in that ATM, there is a provision to turn off and not use the routable headers. And we turn off the routable headers, so there is no source and destination IP address. Self-propagating viruses are looking for IP addresses they can get to, known vulnerabilities they can exploit. And our non-routable protocol break, one, never allows the destination IP address never ever to be known by the source, and vice versa. So those viruses don't have the ability to get beyond the data diode because IP addresses, MAC addresses, and identifiable information of the assets is never allowed across the diode. So the question is what are the various different protocols, and it runs the gamut from file transfer, FTP, SFTP, syslog, email, OPC, UA, DA, historian. I mean, the list goes on and on and on of various different control interfaces that we can support. Okay. So to wrap it up, as Scott talked about, right, one of the first and probably the more difficult aspect for an asset owner is to map your networks and eliminate those unnecessary connections. So you got 583 connections out there. A lot of them are probably TCP/IP, and that's the way the world works. But those end up being vulnerable. So understanding your connections and putting them into various different categories of then how you can assess how to move data one way in or one way out, or do you have to have bidirectional TCP/IP, right? So convert as many of the connections to one way outbound, convert remaining connections to one way inbound, and then the DHS talks about for those handful of connections that have to be TCP/IP across the boundary for command and control, put it on a single device so you can turn it on and turn it off when you need it and when you don't. So limit monitoring, and for the remaining two-way connections, the piece that I'll say out there in the industry is with the implementation of data diodes and the large asset owners that have them deployed, they have gone back to many of their system suppliers and mandated that the OEMs start working on conversion of their data flows, eliminating the TCP/IP connections and converting a one-way push in order for those systems to work. So that is out there. And then implement defense in depth, because the data diodes do a lot of things, but they don't do everything. And as Scott said, there's multiple different ways to skin a cat. And people always ask us, well, why can't we just implement data diodes and know that we're done? And my simple answer to that is, well, data diodes don't train your employees to not click bad links. And phishing attacks are some of the most vicious out there. So data diodes are not a silver bullet. And remember, don't step in it. We can help you out.